Hi class, I'm going to go over how to draw a normal distribution. Remember, when we talk about distributions, we describe its shape, center, and spread. And the shape for a normal distribution is symmetric, unimodal, and bell-shaped. So there are two ways to start drawing a normal distribution. The first is to draw a curve and then put a scaling on it. The second method is to draw a scale and then try to produce the curve. The key words that we have to learn are concave and concavity, have to do with concavity. So concave up and concave down. Concave down means that if it were a rainy day and water were falling on this, it would fall off the mountain. Concave up would be a valley, and water can be caught in this valley. So basically a cup turned upside down or a cup facing up, okay? This curve has curvature, and we want to identify the point where it switches from concave up to concave down. Okay, I have automatic shape recognition, so it thinks that I'm trying to draw a triangle, but I don't want to draw a triangle. Okay, so we have concave down in this region, but there's a flare in this region that if we were to repeat this pattern, right, there would be a region that you would define or describe as concave up. There's a point of inflection. The point of inflection on this curve is where it stops and makes a switch. So it's going to be in this region. Okay. To be more precise, it's difficult, but to eyeball it, that's all we need for this class. Okay. So I would say the point of concavity change is about here, and the center is here. So this would be our first standard deviation. Take into account how wide this marking is. You find your second, and then you space out and you get a third. So here's one. So my left one is not as symmetric. It's not as good. And obviously you're going to have to practice. And I need to practice with my stylus on my computer. But that would be two, and then maybe the third would be out here. Okay. So it wasn't as symmetric as I would have liked, but this is a good start. Okay. So I'm going to repeat the process and to practice. So I'm going to erase through the canvas. Oh, I want to get rid of my form. Let's see. Okay, so let me try that again. I have a horizontal line, and I go up and I come down. Okay. The change in concavity is about here, and about here, obviously I emphasized it on my way down. There's symmetry. So this distance here is what I want to take note of, and same on the left. Okay. You'll notice that by the time the curve flares and you reach this third marking for standard deviation, it's the distance between the curve and the graph should diminish to almost zero. I mean, it's practically not there. I'll show you how to draw this, how the computer draws it, and you'll see that the gap is minuscule, but when you zoom out, it looks like it's touching, right? Okay. So that's the first method. Let me do the second method. The second method instead takes into account a scaling. So I could just write 3 marks to the right from the center and 3 marks to the left. Oh, I have grid paper on, so let me see if I actually did that right. That's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so I have to do the same to the left. Okay, what you want to now do is envision light grid lines. Okay, and then our horizontal line. So you can make a box, because not all of us are great artists, but having a framework lets us decide where we're going to start our curve. So you want to draw a bell in the first cell, then flare out symmetrically, and then finish to the point of contact with the horizontal axis. So that's pretty much drawing the scale first and then the curve.